So classified paper 6 topic chemicals energetic. The first question from this topic. A student investigated the temperature decrease when sodium hydrogen carbonate react with hydrochloric acid. Using a 25 cm cube of a measuring cylinder, a hydrochloric acid was poured into a conical flask. Yeah, the temperature is decreasing. It's obvious that the reaction, it shows the reaction is endothermic, because if temperature increase, the reaction will be exothermic. Initial temperature of an acid was measured and 1 gram of a sodium hydrogen carbonate was added into a conical flask. At the same time as a stop clock is started, the acid and the sodium hydrogen carbonate mixture in a conical flask were stirred continuously using a thermometer. The temperature of a mixture after 1 minute was measured and the conical flask was rinsed with a distal bottle. The experiment 2 was repeated with 2 grams. Experiment 3 was 3 grams. Experiment 4 was 5 grams. Experiment 5 was 6 grams. And experiment 6 is of 7 grams. So as you can see the table, use a screen annotation, and I want to complete the thermometer readings, initial and the final. Just a minute, just let me align my screen, just a minute, then you will. Yeah. Use a screen annotation to complete the initial temperature, the final temperature, temperature after 1 minute, and the how much temperature decrease. The first one, this is 22, 22, 22. This one is it's between 22 and if you see, this is between 22 and 23, so it's 22.5. So 22, 22, 22. But being a science student, whenever you complete any column, you should always use the same number of the significant figure. So as you can see, this one 22.5, there are 3 significant figures. So all this should have 3 significant figures. So I will write 22.0, 22.0, 22.0, 23.0. To make the same number of the significant figure, keep this in mind. Then this was 19.5. This is 17.5. This one is 14.5. This one is 13.5. This is 14.0. Why? Because I want all to be in the same number of the significant figure. And then use calculate the temperature difference. So basically, if I erase all, see, the question is you have to read the thermometer. So this is 20, this one is 21 and 22. So this is 22. Then this one is 15, 16, 17, 18 and 19. So this one is 19. And how much the temperature has decreased? So when you simply subtract them, you will get the decrease in temperature, which is, this is 19.5, I guess, because it is between 19 and 20, so it's 19.5. And then when I take a temperature difference between them, so 22 minus 19.5, so it's equal to 2.5. So the temperature difference is 2.5. Then same thing, this is 20, 21 and 22. So this is 22, but I should write same number of significant figures. So it's like 22.0. This one is 15, 16, 17. So it is 17.0. And when I take the difference, 22 minus 17.0, it's equal to 5. So this will be equal to 5, but I'll write 5.0. Same here, this is 22.0. This one is between 14 and 15, so 14.5. And when I take a difference, This will be 7.5. Then this one is between 22 and 23. So it is 22.5, 11, 12, 13. So it is between 13 and 14. So it is 13.5. And when we take the difference, this will be 9.0. This one is 23.0. This one is 14. So when 14.0, when we take a difference, again 9.0. And the last one, the seventh one, it's 21, 2, 3, 23 and 14 again. So it's the same. So 23.0 and 14.0. Again, it's the same temperature change. So we have to read the thermometer and just work out the initial and final temperature and then the temperature difference. The next part, we have to plot the results from experiment 1 to experiment 6. Draw two best fit straight line through the points. The first straight line should be from the first 3 points and must passes through origin 0, 0. And the second straight line, which is the last 3 points, and that must be horizontal. Extend your straight line so that they meet each other. So we have to plot a graph for temperature decrease. We have to plot a graph for a decrease in temperature and the mass. So you can see the mass is 1, 2, 3, 5, 6, and 7. And the temperature decrease is the last column. So I will rewrite these values because I want to use them. So I will rewrite the values here. Like when it was 1, the temperature decrease was how much?
2.5.
2.5. Then the second experiment.
5.
When it is 2, it is 5. When it is 3, it is 7.5. 7.5. When it is
And
5,
the last 3, 9.
yeah. Because when we take a, how much? Sorry?
9.
9.0, yeah. And then when it is 6, it was 9.0. And when it is 7, it is also 9. So I have to make a graph for mass and the temperature decrease or the temperature change. So here you can see the mass of a sodium hydrogen carbonate and the temperature decrease. So we'll mark the points. First, we mark a point when the mass is 1, the temperature is 2.5. So 1 and 2.5. So where 10 boxes equals to 2. So each box equals to 0.2. So this will be 2.2, 2.4, 2.6. So between 2.4 and so this will be 2.5. The first point, is it clear? When
Yes,
the mass is 2, when the mass is 2, the temperature change is 5. So 5 is between 4 and 6. It should be 5. So 1, 2, 3, 4, 5 boxes. So that will be 5. So when mass is 2, the temperature is, because each box is representing 0.2. So 4.2, 4, 6, 8, and 10. So this will be 5. So 5 and 2, that's the point. Then 3 and 7.5. So 3 and 7.5, this will be 7, 7.2, 7.4, and 7.6. So between them will be 7.5. And then 5 and 9. So 5 and 9. So it will be between 8 and 10. So 5 and 9. Then 6 and 9. Then 7 and 9. And what this said, this says that you draw two straight lines. The first straight line should be from the first 3 points and must passes through origin. So when we join the first 3 points and passes through origin, so this will be the first straight line. Yeah, whenever you're doing a graph should always be done with pencil. So join these 3 points with a straight line and through the origin. Or it's better you start from origin and join these 3 points. And then the second straight line should be the last 3 points. So when we join the last 3 points, and we should intersect the two lines. So that's how the graph should appear or look like. Is it clear, this part?
Yes.
Then the next part they're asking, from your graph, determine the temperature decrease and the mass of a sodium hydrogen carbonate and show clearly on the grid. Like we have the two lines are there. One of the line we join the first 3 points through the origin, and the second is we draw the horizontal. Show clearly on the grid how you work out. So determine the temperature decrease and the mass of a sodium hydrogen carbonate where the two lines meet or intersect. So where the two lines meet or intersect, we want to determine what is the temperature and what is the mass. So how to work out the mass? So when we draw a line on x-axis, we'll know how much mass is there. So what is this mass? Each box is representing 0.1 on x-axis. So after 3, there are 6 boxes. So what is this point? Each box is on x-axis, each box is representing 0.1. Because 10 boxes equals to 1, so each box is 0.1. So this will be 3.1. This will be 3.1, 2, 3, 4, 5, and 6. So this is 3.6. So this point is 3.6. So the mass is 3.6. And what is the temperature change when you draw a horizontal line? So that will be 9 or 9.0. So you have to show this on the graph. You have to draw these lines. 1 mark is for just drawing these lines to show what is the mass and what is the temperature. So we will write here that the temperature decrease was 9 degrees and the mass of a sodium carbonate was 3.6 grams. Explain why the temperature decrease become constant for a higher mass of a sodium hydrogen carbonate. So what might be a reason? Like when we use a high mass like 5, 6, and 7, the temperature change is not, there is no change in temperature, decrease in temperature is same for all the cases. So what might be a reason? The reason is like sodium carbonate. Now sodium hydrogen carbonate is in excess or the acid might be used up. As we are using a greater mass of the sodium hydrogen carbonate, yeah, that's good. Acid is used up or sodium hydrogen carbonate is in excess. So you write acid used up, that is fine. Or you can also mention sodium hydrogen carbonate is now in excess. That's why it does not affect the change in temperature much. Any one you can mention as it's a 1 mark, either acid is used up or sodium hydrogen carbonate is in excess. The investigation was repeated using a dilute hydrochloric acid in half concentration, but same volume. On the sketch, on the grid, sketch the graph you expect and label that as D. So what we are doing, we use a half concentration. So how to complete this? If we use a half concentration of acid, yeah, lower concentration, less reaction will be there, or the reaction, the temperature change will not be 9. Like here, here what happened? When we join the 2 points, This is for the first part when we did. Now the question is, we are using a acid of lower concentration. Less concentrated acid means like few particles of acid in the same volume. Say first we use 25 cm cube of acid, and the second when we repeat the experiment, we are also using 25 cm cube of acid. But the only difference between them, in the first one, the acid concentration was high, means more acid particles were there. In the second experiment, the acid concentration is low, so there are few particles of acid. So how the temperature decrease will affect? So the temperature decrease will be smaller. Like when we use a high concentration, the temperature decrease was about 9, the change in temperature. But when we use less concentrated acid, so what will the temperature? Like half concentration, so temperature decrease will be 4.5. So the sketch will be same, but at a lower temperature. And the mass of sodium hydrogen carbonate, which was used here, how much sodium hydrogen carbonate was used for a complete reaction? We used 3.6 gram of sodium hydrogen carbonate. But as we reduce the amount of the acid, so amount of sodium hydrogen carbonate will also decrease, so it will be 1.8. So around 1.8 and the temperature about 4.5. This reaction will finish. Like the temperature will be 4.5. As we use low concentration, so low concentration means less particles are there. So we have to sketch on the same grid, and we have to label that as D. So around 1 or 2.5, and the temperature change will be like here it was 9, so it will be around 4.5, 4 or 4.5 somewhat here, and then it will be horizontal line. Why half sodium hydrogen carbonate? Because the acid concentration is also like amount of the sodium we are adding, like we are adding 1 gram, 2 gram, 3 gram. But as we reduce the amount of acid, so for a complete reaction, here in the first experiment, for the complete reaction, we need 3.6 gram of sodium hydrogen carbonate. But as we reduce the amount of acid, the concentration of acid, so we need less amount for a complete reaction, like 1.8 or 2, any value you can mention because the sketch, but it should be lower temperature change as well as smaller amount of sodium hydrogen carbonate will react. Because here more particles of acid, so more hydrogen carbonate or sodium hydrogen carbonate, few particles of acid, few hydrogen carbonate are required. So whenever we use the same amount but lower concentration, the amount of the product will also decrease and less amount of reactant is needed for a complete reaction. Then the last part suggests two changes that you could make to the apparatus that improve the accuracy of the result. For each stage, you have to mention, look, for these type of reactions, especially the first thing, most of these questions, the answer are there in the question. If you read the question, the first line, it is written using of measuring cylinder for acid. So if I'm using a measuring cylinder is not the accurate one. So for 25 cm
So
cube,
we can use puree.
yeah, pipette is more accurate rather than burette. The reason is because it's 25. It was a variable volume, variable volume was there, then pipette, then burette. So here in this case, I should use a pipette that is more accurate. Your pipette can handle 25.0 cm cube accurately, like fixed volume. Second thing, if you read the question, what we did, we use a conical flask. So we use a conical flask for this, but as the temperature change, whenever a temperature is changing, the conical flask is not a good insulation cup or a flask. So what we should use a polystyrene cup, because if in a polystyrene cup, it will not allow the heat energy to escape. It will not allow heat energy to enter or to escape. Like it's a good insulation. So the temperature change, you can also mention lag the big, but because I mentioned by changing the apparatus, so you must change the apparatus. Lagging is addition to the apparatus. They did not ask for state what addition is made to the apparatus. They asked what changes are made to the apparatus. That's a question. If the question is what addition can be made to the apparatus, then your lagging is right. But suggest two changes that could be made to the apparatus for accuracy. Thermostatically controlled water bath. It is because we don't want to maintain a temperature here. So we don't want the heat to enter or to escape. That's why the water bath is also not acceptable. So the two changes, we will use a pipette, and instead of measuring cylinder. The water baths are normally used if you want to keep the substance warm for a longer period of a time. An explanation, it is more accurate. And the second change, we will use polystyrene cup. So the second one, we use polystyrene cup. And it is insulate or reduce the heat loss or gain. So that's how we should carry out this experiment.